All right, this is the back of the opener sheet. Basically, we're given a binomial situation where we flip a coin 100 times and we're counting the number of heads. This is sort of a review from the other day. We're going to use the calculator functions to find these things. So it says x is binomial, and we're flipping 100 times, and the probability that we get heads is 1/2. So x is a binomial random variable where n is 100 and p is 1/2. So the first one says find the probability that you get more than 59 heads. So one thing is, how do you communicate your solution if it's not satisfactory to just write down what you put in the calculator? Well, the first thing you're going to do is you're going to define the random variable, which is done right here. Okay, it says x is the number of heads you get out of 100 flips. If you're going to use x and it's not defined, you should define it. And then the next thing we're going to do is we're going to actually say that x is binomial. All right? Then we're going to write down the probability that we're asked to find. Find the probability you get more than 59 heads. So that's the probability that x is greater than 59. Okay, now we know the calculator will not find greater than straight up. We know we'll only find less than or equal to. All right, so if you look on the right here, I've written all the possible outcomes that we could get for the number of heads from 0 to 100. What we're trying to find is greater than 59. So that would be from 60 to 100. So what's not included in that? Less than or equal to 59. So I would rewrite this as 1 minus the probability that x is less than or equal to 59. Okay? We know the calculator will easily find this probability. Okay? So we'd put in the calculator this. Let me clear this. We would do 1 minus binom CDF 100, comma, 0.5, comma, 59. And that's the answer. There's about a 2.84% chance that we get more than 59 heads, which might mean if we get more than 59 heads, we may be very surprised because it's very unlikely that that would happen. Okay, maybe the person's a good coin flipper, maybe the coin's weighted, or maybe it's just luck. There is a 2.8% chance that that would happen. If it happens, yeah, maybe it happens, okay? So here's the answer to number 1. And notice I'm not really writing that binom CDF that I'm doing here because it's not an acceptable way to communicate it in terms of the AP test or in terms of tests in this class. So I'm writing this stuff, how I'm finding it. Okay, number 2, find the probability that we get between 35 and 59. So that's between 35 inclusive, so we're including those two. Okay, so if I highlight what I'm trying to find, I'm trying to find between 35 and 59. Okay, so let's see. Yesterday we talked about, what if we took the probability that x is less than or equal to 59? That would be all of this. What do we need to subtract out of that to get what we want? Well, we need to subtract out this part here. So we're subtracting out less than or equal to 34. Okay? So we're going to just put that in the calculator. 2 binomial CDFs. I'm just going to write down what you put. So I would just type in this in the calculator, okay, and I would get the answer here is 0.97066. So it's very likely that we would get between 35 and 59 heads. All right, what's the probability that you get less than 35 heads? So that would be essentially all this stuff. Probably x is less than 35. Well, the calculator doesn't find less than straight up. It finds less than or equal to something. So the probability x is less than 35 is the same as the probability x is less than or equal to 34, and I'm just going to put that in the calculator, and I get, I think what it does is it puts it in scientific notation, where it says it's like 8.95 times 10 to the negative 4th, but that's actually equal to 0.000895. Okay, now, Number 4 is a typo. It says add the answers to 1 to 4. Why don't they add to 1? They do add to 1. Okay, so if we look at why that makes sense, well, first of all, first probability we found was more than 59. That was all these. The next one we found was between 35 and 59. That was all these. The last one we found was less than 35, which includes all of these. That's everything. So they do. It was a typo. All right, final thing. Find the mean and the standard deviation of x. The mean of x, that's just 50. The standard deviation of x, well, we just found that formula. It's the square root of np times 1 minus p. Plug that in. 100 times 0.5 times 0.5. 100 times 0.5 is 50. Half of that is 25. This is the square root of 25, which is 5. So the standard deviation here is 5. All right, you're about to be given another problem where we're going to take this scenario and we're going to say, okay, the mean is 50 and the standard deviation is 5. We know that the number of heads that we get is a binomial random variable. But suppose we use the normal model with a mean of 50 and a standard deviation of 5. How close would we get to getting these results? Okay? Now, it is very possible that you will not have time to either watch the next entire video or even watch it at all. I'm saying now, you are responsible for going and looking at that video on your own time if we don't get to it in class on this day. Okay, we will address it the next day in class, but you are responsible for looking at this video if we don't get to it.